Find all zeros, both real and imaginary, of the following polynomial. Okay, so this polynomial, f of x equals x to the fourth plus 2x to the third minus 3x squared plus 24x minus 180, could have zeros at any point. In order to determine, or to at least get started, we need to get some initial rational zeros if possible. And the easiest way of doing that is just taking a look at the graph. So I'll pull up the calculator here and graph this. So x to the fourth plus 2x cubed minus 3x squared plus 24x minus 180. If I graph this in the standard viewing window, so I'll hit zoom and 6 to get the standard viewing window, then this should give me some initial zeros. Now, it's not a great graph of this polynomial because usually polynomials are nice smooth curves. It's just that this one increases so rapidly, it's just way outside of the viewing window. But that's okay. We don't need to see the entire thing. We just need to see where it's crossing the x-axis. So that looks like it's happening at, let's see, 1, 2, 3, 4. So -5 and +3. So let's go ahead and state that -5 and +3 are zeros of this polynomial. Now, we don't know that for certain just yet. It could be some value very close to these, but not exactly, but in all likelihood it is these. But to prove it, what we would need to do is factor those out using synthetic division. So we take the 0, factor it out of this polynomial, 1, 2, -3, 24, and 180. Just bring the 1 down. 1 times -5 is -5. This adds up to -3. That's 15 or 12. -5 times 12 is -60. 24 minus 60 is -36. And if I multiply that by -5, I get +180, but that's supposed to add up to 0. Oh, there's a negative in front of that. That's the problem. Okay, so I apologize for that. Add these together, that can become 0. So that works out. So this is a 0 of the polynomial. Now, these are the coefficients of a cubic polynomial that's reduced by 1 degree because we factored out a 0. And what we can do is we can take that cubic and then factor out this next 0. So just take the remaining coefficients here. Bring 1 down. So 3 times 1 is 3. That adds up to 0. That's 0, 12, +36, and that adds up to 0. So now these are the coefficients of a remaining quadratic, which would look like x squared plus 12. And what I'm going to do is set that equal to 0 in order to determine the remaining zeros. Because once you get your quartic down to a quadratic, you can then just solve the quadratic using any methods that you can there. And you've got a lot available to you, the quadratic formula and so forth. But once you solve that remaining quadratic, then you're finished. So here, if x squared is equal to -12, if I take the square root of both sides, it's x equals plus or minus square root of -12. And the square root of -12 can reduce. So 12 is 4 times 3. 4 can come out from underneath the square root and become a 2. The negative can come out as I and leave me √3. So the remaining zeros here, 2i √3 and -2i √3. Or if you use the plus or minus notation, that's fine as well.